Here we have a SAT math problem. Okay, let's go to the question. In the figure above, O is the center of the circle. If the area of the circle is 100 pi and the measure of angle POR is pi over 6 radians, what is the area of parallelogram OPQR? Okay, in this question, we have to find the area of this parallelogram OPQR. Okay, if I want to get the area of a parallelogram, there is a formula, that is base multiplied by height. Okay, so when I multiply the base of the parallelogram and the height of the parallelogram, I'll be getting the area of the parallelogram. Okay, here when I look at this parallelogram, OR, the line segment over here represents the base of the parallelogram, and the height is a vertical line. Let me draw it. So the vertical line I have drawn over here, the blue color line, represents the height of the parallelogram. Now let's consider the base of the parallelogram, that is OR. Actually, this OR represents a radius of the circle, and using this piece of information, that is the area of the circle is 100 pi, we'll be able to get the radius of the circle, and the radius can be considered as the base of the parallelogram. Okay, now let's find the radius of the circle. Let me take the given area, that is area of a circle equals to 100 pi. We know that the formula to find area of a circle is pi r square equals to 100 pi. Okay, now I have written the formula to get area of a circle. This r represents the radius of the circle. Okay, now let's solve for r in this equation. Let me divide both sides of this equation by pi. Then this pi will cancel out. Here pi will cancel out. I am getting r square is equal to 100. Okay, now to solve for r, I have to get up the square over here. For that, we have to take square root on both sides. When I take square root on both sides, the square root and square will cancel out. I am getting r on the left side. On the right side, we have square root of 100. Square root of 100 is just 10. Okay, now I got the radius of the circle, that is 10. So that's the base of the parallelogram. That's the length of OR. And this OP also, the radius of the circle. So the length of this OP is also 10. Okay, now we got the base of the parallelogram. Still, we need to get the height of the parallelogram. That is a blue color line segment we have over here. Since it's a vertical line and this OR is an horizontal line, so we have a right angle over here. And let me take a point, letter M over here. Okay, and also let me assume the length of the line segment PM as h. That is, this h represents the height of the parallelogram. Okay, now my aim is to get the value of this h. For that, let me consider this particular piece of information. That is, the measure of angle POR is pi over 6 radians. POR over here. So the angle measure over here is pi over 6 radians. Now, let's consider the right triangle POM over here. In this right triangle, let's consider the angle measure over here. So the side PM, which is opposite to this angle measure, has to be considered as opposite side, and the side OP is hypotenuse because this is opposite to the right angle. Okay, I know the length of hypotenuse, and I have to find the length of opposite side, which is the value of h. Okay, so we have to consider trigonometric ratio in which we have opposite side and hypotenuse. So that is sine. So we have to take sine and this angle measure, because based on this angle measure, we have considered the side PM as opposite side. So sine pi over 6 equals to opposite side over hypotenuse according to Seccato. Okay, so if I want, I can convert this radians to degrees. So for that, we have to plug in 180 degrees for pi. So when you divide 180 degrees by 6, I am getting 30 degrees. So the degree measure, which is equal to pi over 6 radians, is 30 degrees. So now we can replace this pi over 6 by 30 degrees. Then I'm getting sine 30 degrees equals to the length of the opposite side. That is unknown. So actually we have h for opposite side. We can plug in h for opposite side. And for hypotenuse, we have 10. Okay, so what is the value of sine 30 degrees? The value of sine 30 degrees is just 1 over 2. Okay, so here 1 over 2 equals to h over 10. Now let me multiply both sides of this equation by 10 to get up the denominator 10 over here. So when I do so, this 10 will cancel out. 2 goes into 2 1 times and 2 goes into 10 5 times. I'm getting 5 on the left side. On the right side, we have h. Okay, now I got the height of the parallelogram. Okay, now we have both the base and height of the parallelogram. Now we can get the area of the parallelogram. Let me do it. So area of the parallelogram OPQR equals to base multiplied by height. Let me write the stuff over here. So the base of the parallelogram is 10 and height of the parallelogram is 5. 10 times 5 is 50. Therefore, the area of the parallelogram OPQR is 50 square units.